Hi guys, my name is Reagan and today we are going to look at a demo for a first notice of loss system that I have built on top of Raspberry Pi. Right, what you're looking right now at is the model that I have built. Just let me walk you through all the different components and on high level what they are. So if you see this here, the green thing, the green board that you're looking at, that is the Raspberry Pi, which is currently turned on right now. On top of that, we have a Pi hat. It's basically for controlling of the motors for these two wheels that are there. The motors are underneath, and this here is the battery pack, which is used to operate, which is used to power the motors through the Pi hat. This here is the pan and the tilt module, right? It's basically used for taking the pictures of the surrounding. It does this pan and tilt motion, which takes the pictures of the surroundings with the help of the camera, which is mounted on top of the pan and the tilt module. This is a breadboard here, which if you look closer, this is the breadboard, and what I've done is that I basically used it for some quick connections to all the different components that are there with the Pi. This right here is the ultrasonic sensor, which is used for capturing the distance between the closest obstacle. This here, which I have stuck together, is nothing but the battery pack, which this is responsible for powering the Raspberry Pi that we have here. And along with that, this here is a carton, is a box that I'm going to use. I've taped a number plate here. This number plate is going to be read by the camera here, and it's going to figure out the number from just that picture. Okay, so this is a model here that we'll be doing a demo for in a bit. Thank you. Okay, so what we have here is the whole architecture diagram for the first notice of loss system that we just saw the model for. This diagram basically represents all the different components that we saw on the model. This is the Raspberry Pi over here. This is the pan and the tilt module, and this is the ultrasonic sensor. This basically sends the information regarding the reading back to the Raspberry Pi. The Raspberry Pi is going to calculate the distance, and if the distance falls below 0, it's going to take a picture here. That picture is going to be sent to the Watson VR service. This is the Watson VR service. This Watson VR service is going to determine if there is an accident or not. It's going to use AI to determine if there is an accident or not. What we'll have to do here is basically create custom classifiers for Watson VR service and help and train it before this, train it so that it can recognize those images that we have. Now, once it will send a response back to the Raspberry Pi, the Raspberry Pi is gonna do some initial filtering and then send data to Watson IoT. Now, I've connected the Pi as a device to Watson IoT, and you can see that right here. So this is the, let me close this. The name that I've placed for this device is Mac. It's just the name that I decided to give. These are all the devices here, and this is the device that I'm connecting it for. If you click on it, it will give you all the device information. I've set the device type as first notice of loss device type, and it will show all the, currently there are no events because this is not connected yet to my device. When it is connected, it will show that it is connected here. We will see that in our demo. See, there is all different information and the last connection logs that you can see here. Okay, let's go back here. It will send that information to Watson IoT. And what we have also done is set up some cloud rules on the IoT platform. Let's go back and look at the cloud rule. This is basically the cloud rule that we have. What it does is that the image, the VR image that is analyzed, and the data is sent to Watson IoT, which says if the score is more than 70 and the class is equal to vehicle. Now, in an actual scenario, this will not be vehicle. It should say something like an accident, right? If the score is 70 and the class is accident, then do this. Score is basically the confidence level that the VR service has for if it's an accident or not. The actions that we have selected here is, there are two actions. One is send an email. It's going to send an email to me. And second is take pictures. Now this is a special type of action which executes a Node-RED flow, right? Let's take a look at the Node-RED flow here. This is the Node-RED flow. This Node-RED application is again installed on Bluemix here, okay, along with our other applications. So this is basically an HTTP node here. The HTTP node does nothing but it's like it will accept the request from this IoT platform, the rule. It will accept that request. It will then this is basically a function node which will set the data saying that this is the command that we are going to send. It will set that data in the payload. Then it will send this command to the device back. So what we have done here is we have set up the device here using and this is connecting our device, the Raspberry Pi device. The device type is FNOL and output type is device command, which means that this will send a command to our Raspberry Pi. So whenever this rule satisfied, it's gonna send take pictures command or the process FNOL command back with some data that we want. Okay, we're not going to look at the properties that we have. So that's what this is going to execute. And that's what it says here. The cloud rules goes to email, Node-RED sends back a command here. When this receives the command, it's going to continue the FNOL process. This tilt and pan is going to take 180-degree pictures. Once the pictures are done, it will then send it back to the onboard license plate determination program, which will try to take from the pictures. It will try to using OpenCV and some artificial intelligence. It tries to find out the number plate, okay, the actual numbers that are on that plate. If it does not find, it's okay. What it will do next is trigger this case. Okay, this address is an external service which the Pi directly talks to. And it will upload all the supporting documents after creating that case, and if additional data is there, it will send a license plate number also. Okay, so this is on a high level what the flow is gonna be like.